Hi everyone, what is the GCF of 24, 42, and 60? Let's find out here in this video. The concept of GCF is very important in mathematics since it is more of patterns and commonalities. It is foundational to most of the topics in algebra, trigonometry, and even in calculus. So let's start. What does GCF means? Alright? So from the word itself, it is the greatest number that can divide the given numbers. And can divide the given numbers means it represents a divisor. Alright? So in order for us to understand the concept of this, we must know first the concept and the purpose of division because we're going to deal with a lot of process of divisions here. When we say divide, alright? When we say divide, we are splitting something into many parts. So meaning the purpose is to distribute, all right? The purpose is to distribute. Or in other words, it is the result of fair sharing. And for you to have a fair sharing, you must have a remainder of 0 when you divide, all right? So let's have an example. Let's get the GCF, all right? Example, we're going to get the GCF of 4, 8, and 12. All right. So since these numbers are even, let's divide this by 2. So if we divide this by 2, we're going to have 4 over 2, which is 2, 8 over 2, which is 4, and 12 over 2, which is 6. You have answers 2, 4, and 6, and it means 4, 8, and 12 have a common factor, which is 2. But since the results are even and still divisible by 2, it means that the GCF of 4, 8, and 12 is not 2. All right? Is not 2. And since 2, 4, and 6 are divisible by 2, how about if we try to use 4? All right? So let's say, for example, we're going to use 4. Let's use this. We're going to have 4 divided by 4. This will be equal to 1. 8 divided by 4, this will be equal to 2. And 12 divided by 4, this will be equal to 3. And since 1, 2, 3 has no common factors other than 1, or we can say that the results are relatively prime, then the GCF of 4, 8, and 12, the GCF of 4, 8, and 12 is 4. Alright? And in here, you can notice that the greatest possible value of GCF is the least value in the given numbers. In the concept of greatest common factor, we must apply the concept of factoring to easily get the GCF. And when we say factoring, we have to express a certain number as a product of its prime factors. Let's say have example number 2. We're going to get the GCF of 12 and 20. So we only have two numbers here, and this time, instead of dividing these numbers by 2 until its result becomes relatively prime, we do the factoring, right? So if we get the prime factors of 12, this will become 2 times 2 times 3, all right? And if we do, or if we get the factors of 20, this will become 2 times 2 times 5, all right? Now, if you put this in table like this, if we put on a table like this and align those factors that are common, we can easily get the greatest common factor. So this will be, they have common factors which are 2 and 2, right? So your GCF here will be 2 times 2, which is equal to 4. It means 12 and 20 have factors in common, which is 4. And since we know in the first part of this video that the GCF serves as a divisor, then we divide the given numbers by 4. So this will become 12 over 4 is 3, 20 over 4 is 5. If you notice that 3 and 5 are the factors that's left on the table, then the next time we get the GCF, we don't have to divide the given numbers to see that the quotients of the given numbers and the GCF will result to it a relatively prime. All right. So you just look on the table and look for the factors where 12 and 20 don't have in common, which are 3 and 5. All right. So let's move on in finding the greatest common factor of 24, 42, and 60. And this time we're going to get the GCF of three numbers, and we have to think of a factor that these three numbers have in common. And it must be the greatest since we are getting the GCF. As we get their prime factors, 24 can be written as a result of the product of its prime factors, which are 2 times 2 times 2 times 3, since 24 has a factor of 8 times 3. All right. So next one, which is 42, can be written as a factors of 6 and 7, and their prime factors are 2 times 3 times 7. All right. That is 6 times 7, which is 42. The next one is 60. We have here 6 times 10. So that would be 2 times 2 times 3 and times 5. All right. And we have to put it in the table so we can basically get their greatest common factor. All right. So as you can see in the table, 24, 42, and 60 have factors in common, which are 2 and 3. All right. So your GCF here will be equal to GCF will be equal to 2 times 3, which is equal to 6. All right. So if we divide these given numbers by 6, the quotient should be equal to the factors that is left on the table. So let's try. 24 divided by 6, this will be equal to 4. All right. So you have here 2 times 2, which is equal to 4. All right. Next one, we have 42 divided by 6. This will be equal to 7. And 7 is left on the table. And last one, we have here 60 divided by 6. So this will be 10. And 2, 5 are left on the table. All right. So since 4, 7, and 10 are relatively prime, then of the GCF of 24, 42, and 60 is 6. So if you have questions regarding this video, you may write it down in the comments section below. See you next video.